This is Algebra 2A, Lesson 3.1, Functions and Function Notation. So we'll start with the definition of a function. A function is a relation such that each input, and usually we use the variable x for our inputs, has at most one output. So I heard one time someone said, think about a vending machine, right? If you push the Coke button, that's your input, your output is a Coke. If you push the Sprite button, your output is a Sprite. But if you push the Coke button and you get out a Sprite and a Coke, that machine is not functioning. You only get one output, okay? We're going to use something called function notation. We're going to replace y equals with f of x. So whatever's in the parentheses is our input, right? Whatever it is equal to is our output. We have the vertical line test is a way to tell us if a graph is a function. So a vertical line test is that a vertical line must pass the graph one time. I'll just draw it. So we have our graph here, and let's say I have a graph, and if I draw a vertical line at this input, any vertical line I draw hits the graph one time. And I can test multiple inputs if I need to, but every one of those is one time. Yes, that's a function. Okay? Versus if I have a graph, and let's say it looks like that, and I test this input value, he looks good, he only passed the graph one time, but I test this input value, and I'm hitting my graph more than once. If I have multiple outputs at this input, no, that is not a function. Domain is the possible x values. Now, usually this is based on a context. So the lowest possible input value, the highest possible input value, and we're going to represent that as a number less than or equal to x less than or equal to the highest number. Okay, so whatever the lowest x value is to whatever the highest x value is. Range is going to be our possible output values. And we're going to represent that the same way, whatever our lowest possible output value is to whatever our highest possible output value is. Now this is specifically for continuous functions. There's different ways to write domain and range if you have discrete functions or using set notation, but we're going to just keep it simple. Lowest x to highest x, lowest y to highest y for our continuous functions. Okay? Example A, tell whether each relation is a function. So we're going to use our vertical line test on these graphs. If I draw a vertical line at a given input value, if it hits more than one time, that means it has multiple outputs. It is not a function. Every one of those lines, I can test as many as I need to, hit the graph a single time each. So yes, this is a function. If any input value has multiple outputs, right here I hit it once, I hit it twice, no, it is not a function. So check a couple if you need to, just to be sure. Yes, that is a function. Each of those lines hit the graph exactly one time. Check a couple of input values if you need to. Yes. Each line is hitting the graph once. Yes. And the very first value I check here hits it output here, hits output here. No, that is not a function. Your vertical line can only hit your graph one time. When we're looking at tables, we can kind of think about it the same way, but I'm going to look at this one for reference. If I have this input value of 2, notice I had an output down around -1 and an output up around +3. I can't have my input value repeat. I need to have unique input values. So 3, 5, 2, 8, 6, every one of those is a unique value. I'm not repeating into my input values to get different output values. Yes, that is a function. If I look at the second table, I can see input of 1 could give me a -2 or a -1 or a 0 or a 1, or because I have this input value repeating and give me different output values, no, that is not a function. And finally, unique input values. even though it's giving me the same output value every time, that is okay. You can see that vending machine, sometimes Coke is a very popular beverage and there's going to be 3 Coke buttons. It's okay to have multiple inputs give you the same output, but you do not want your input to give you different outputs. Okay, next example, letter B. The graph describes another student's distance from you. What are the domain and the range? So on this graph, we see what is the lowest input value to what is the highest input value. That's going to be our domain. So this graph starts at 0 seconds and goes all the way up to 8 seconds. Our domain, the lowest is 0, the highest is 8, right? It starts here and then travels all the way up until we reach 8 here. Now the range, it's not 0 to 8. It looks kind of like 0 to 8, but because our graph doesn't go below 2 and our graph doesn't go above 8, it's actually going to be 2 to 8. So our lowest possible output value is 2 meters. Our highest possible output value is 8 meters. And this is a continuous function, so we have everything in the middle. Okay, so we're going to look at function notation now. So we said we use f. That letter's kind of arbitrary. We could pick any letter we want, but we're going to call this function f. And the input is going to be 3. So what that means is on our x-axis, our input is 3. And we're looking for what the output value would be. So with an input of 3, we can come up to our graph and see that we would output positive 4. So f of 3 equals 4. Because at 3 seconds, we would be 4 meters away. So we have the reverse situation, find x when f of x is 3. So if f of x equals 3, that means our current output value is 3. So if we are at 3 meters, how much time went by? So I can work my way backwards and see that that comes out to be right between 2 and 3. So we'll call that 2.5 seconds. X equals 2.5. And I'm going to add a S, or I'll add a SEC for seconds. And maybe I'll add an M for meters. Letter C, we have a new function. F of x is 2x plus 5. We're going to use our function notation. Again, whatever's in the parentheses is our input value. We input that into the function. We replace x. So in this case, we're going to be putting our 8 right in here. 2 times 8 plus 5. That is 16 plus 5, 21. Same deal. We have our input value of -7. We're going to input that in the function. 2 replacing our x with -7. 2 times -7 is -14. -14 plus 5 is -9. And the last one is a little different because we don't have the input value. We're trying to figure out what input value would output -4. So I can use my function and set it equal to my output value. And I'm going to use my inverse operations. I'm going to isolate the variable to figure out what x would be. I'm going to start by subtracting 5 from each side. If I have a plus 5, I need a -5 to undo that. 2x drops down, -4, take away 5 is -9. Now I have 2x, which I know a number next to a variable means multiplication. So I need to undo that multiplication with a division. I'm going to divide both sides by 2. The 2 over 2 eliminates because that is 1. I don't need my invisible 1. And then x equals, now I can keep it in fraction form, -9 over 2. That's a nice fraction. I can switch to decimal form. I know that that is -4.5. I'm fine with decimal or fraction, whatever you prefer. And I think that's it for this video. Good luck on the exercises, and please let me know if you have any questions.